Hi everyone and welcome back to Intro to Astronomy. So let's continue our discussion by talking about terrestrial planets. So these are going to be our four innermost planets that would include Mercury, Venus, Earth, and Mars. And like I said before, terrestrial planets have a rocky surface. They're more compact. And I have listed here a few of the major differences. So as we're going along in this lecture, we can kind of think back, okay, what is the difference between these planets? Okay. So the first one is that Earth has a substantial planetary magnetic field. So it's a planet-wide magnetic field rather than a regional magnetic field, like Mars and Earth's moon have, but it protects us from the sun's rays. And we'll talk about that in a little bit later. And then Mars and Earth's moon have regional. So it wouldn't be um, like I'll have a picture in the future, but there is a planet-wide magnetic field that's covering our entire surface that protects us. But Earth, Earth's moon, and Mars have little, I would say, small little regions on the surface um, that have magnetic fields. And another big difference is going to be the atmospheres. So Mercury does not have an atmosphere, and that is mainly due to it being so close to the sun. It is our closest planet to the sun. So the temperatures would be very extreme. Um, but Venus, Earth, and Mars, all three of these guys, have significant atmospheres. And the gases that are present depend on the formation of the planet, the size, and the temperature, the mass, and if it has any sort of life present. And of course, as we know it, the only planet that has life is Earth. Okay. Again, like I said, Mercury does not have an atmosphere, and that is due to how close it is to the sun, how much solar wind it is getting. Okay, so let's go ahead and start with our first planet here. That's going to be Mercury. So this is the closest planet. I didn't put that here, but first planet from the sun, or closest. And it is also the smallest planet in our solar system. It's just a little bigger than Earth's moon, so we kind of compare the two a lot. Um, Orbits closest to the sun, like I said. It has the shortest orbital period, and it's only 88 Earth days. So every, how many months would that be? Like 4-ish months? We'd go around once. That's pretty quick. Um, it has a very thin atmosphere, no moons, no rings. Like I said, has very extreme temperatures. The surface is very hot. There is evidence of water ice near the north and south poles. I don't have a picture of it here. But the reason that they're present is not because, obviously, not the temperature um, of the entire planet, but because we have um, these crater walls at those two areas on the planet, and they shade these areas. And so we can see that there's ice present. And this evidence came from Earth-based radar observations. Okay. The interior and the entire planet is mostly made of metal. Okay. And it's likely to have experienced many giant impacts early in its history. And we can see that by looking at a color image like this. So this is not a typical color image. This image is showing us the different elevations on the planet. So the low regions will be purples and blues. So right in here we have that dark blue, even that purple color right there, right here. Those are low regions. Then we have high regions, and so that would be a red color. So that would be, there's orange, there's some reds over here, and then all of the colors in between are kind of, an in-between elevation. But when we're trying to look at impacts, any kind of crater, we would see some sort of dip like this, where we would have an impact and maybe even some stuff on the side like this. So I'm kind of just drawing a sketch here. But this is the idea of a crater. So this would all be the crust, right? Or the surface that kind of had to move out of the way. And so a crater would be formed by like a meteor that hits the planet and makes a big crater. Um, and the extra material has to go somewhere, right? So it'll go off to the sides, like so. So this is what we would be looking for when we're looking for a crater. So from top view down, we can see there's some low regions. This kind of looks pretty large region here. So I'm not sure if that would be a crater impact. But if you look at this blue spot here, hopefully you guys can see that. I can kind of circle it. Maybe I can do a black color instead. Right there, you can see there's this deep blue color, and then it even has a little bit of an orange color on the very rim. So that would indicate to me that there's been impact happening. And you can see it in some of the other regions too. You can see a lot of small ones here. This one doesn't have as high of a elevation difference, it seems, but you can definitely tell there was some sort of impact. So this makes it kind of interesting that we can study these occurrences, right, from so far away. So let's continue with our second planet from the sun, which is Venus. And Venus is going to be a little different, or very different actually, because it does have an atmosphere. So that makes things look very different than what we see on Mercury. So the size and structure is very similar to Earth and sometimes called Earth's twin um, because they are so very similar. It has a solid surface covered in many different geological occurrences like volcanoes, rifts, mountains, um, volcanic plains, and rigid plateaus. And we have been able to see this. You can see this in this image down here, where we have these big regions of lower altitude. Actually, that would be higher altitude if it's the same color system as the last one. And then we have lower altitude here, higher altitude here. So these would be like mountain regions, right? So we have those. Then we can see our atmosphere here. This is an image that was taken and sent back to Earth. And so we see the rocky surface of Venus. So I know that this is kind of a lot of information right here. The average surface is less than about 1 billion years old. That's another tidbit. So this means that there has to be some sort of um, volcanic occurrences, right? Because that's less than 1 billion years old is less than 4.5 billion years old when everything formed. So there must be some kind of geology going on the planet. Here's a bit more info on Venus. So this is going to be the hottest planet in our solar system, and you would think that Mercury would be the hottest, but um, this is due to the difference in atmospheres. So Mercury, we saw, didn't have an atmosphere, right? Venus does. This atmosphere is very toxic. It's hot um, and denser than the other. Um, what? I know. Sorry, I'm getting distracted. Um, it traps heat inside, and that's due to the composition of the atmosphere. So if you look here on this table, this is in table 10.2, chapter 10. Say chapter 10 here. We can look at the different atmospheres. So Venus here, we can see has a lot of carbon dioxide, a lot of CO2. Versus Earth. We don't have a lot of CO2 here. We have 0.03% of our atmosphere having CO2. Most of ours is actually nitrogen. So, with that information, we have a much different atmosphere here. And with that level of CO2, we get something that's called a greenhouse effect. And what it does is it traps all of the heat in that it's getting from the sun, um, and it just continuously gets hotter, right? So it traps the heat, creating a runaway greenhouse effect. And so it's the hottest hottest planet in our solar system, with surface temperatures hot enough to melt lead. Okay, so very, very hot. Um, it is permanently covered in thick, toxic clouds of sulfuric acid. So it is very toxic, like I said. Okay. Um, I want to point out a little bit more about the atmospheric composition here when comparing it with Mars. So Mars has a pretty similar atmosphere, but the main difference here is that Venus has a larger surface pressure. Um, and it is more massive than Mars. So Venus and Earth are very similar in mass, but Venus and Mars, Mars has a much lower, so lower mass than Venus. Okay, so that is going to be a huge difference between these two, and we'll look at Mars in a little bit. So few other things to say about Venus is that it rotates very slowly on its axis, but orbits the sun in 225 Earth days. So it takes it 225 Earth days to travel around the sun, but rotates very, very slowly about its axis. Its rotation is actually pretty interesting because it rotates backwards on its axis compared to other planets in our solar system. So on Venus, the sun rises in the west and sets in the east, versus what we see on Earth, the sun rises in the east, sets in the west. So that's something pretty interesting on Venus. Okay. Um, Let me go ahead and pause right here, and then we'll start talking about the other two planets that are terrestrial.